Let me know if I'm audible.
I'm Dr. Sen.
Hello. Hello. Let me know if I'm audible. Hello. Let me know if I'm audible. Hello. So welcome everyone to this session of signals and systems. The topic that we are going to cover today is a continuous time convolution. So what is meant by convolution? Okay, let us understand this. For example, let us say you consider LTI system. I'm sure everyone understand what is meant by LTI system. The LTI system is the one which is linear as well as time invariant. Am I right? I repeat, LTI system is defined as linear as well as time invariant. Okay, what is meant by linear? See, linear is that system which satisfies superposition theorem, which satisfies additivity property, which satisfies homogeneity property that we have already seen in the last lecture. So that system is considered to be the linear system. And what is meant by time invariant system? See, when I say time invariant system, it means for a particular system, if you apply input as x of t and assuming the output is y of t, then for input applied, let's say x of t minus t naught is going to produce y of t minus t naught. Just check it out. The amount by which this input is delayed, by the same amount output is also delayed. Can you see that? So such system is considered to be a time invariant system. I hope you understand my point. So time invariant system is such system if input is x of t and let us assume if output is y of t, then for input x of t minus t naught, you get output as y of t minus t naught. Next time, if you apply x of t plus, let's say, beta as input, y, that is output, also gets advanced by the same amount. So whatever treatment that you give to input, the same happens with output. And that's the reason why we say that such system behavior is not changing with respect to time. It remains same. And that's the reason why it is called as a time invariant system. Of course, if the system is linear also and time invariant also, such system is called as an LTI system. So assume for the system, let's say, if you apply input as del of t. So what is meant by del of t? Yes. Is there anybody who can answer me? What is meant by del of t, guys? It's a very simple question. Come on, guys. What is del of t? Del of t is defined as an impulse input. Then, if the input is impulse input, of course, the output is something called as response given to impulse input. Therefore, the output is called as an impulse response. Such impulse response is denoted by letter that is h of t. Okay, So if del of t happens to be impulse input, h of t is called as an impulse response. I hope you understand my point. Okay. So for example, if you apply del of t input, what you are ultimately getting is h of t. Then let's say if you apply input as del of t minus t naught, let's say, then output h, that is output impulse response, will also get delayed by the same amount. I hope you all are understanding this. That is h of t minus t naught, isn't it? Okay, let me know if you are understanding this, guys. If you have some query, you can definitely ask me. If you have understood this, let me know, guys, through the chat box that you are understanding this. Okay, so for impulse input, as we said, the output is impulse response. So for del of t, output is considered as h of t. If the input is del of t minus t naught, then the output is h of t minus t naught. Yes or no? Next, if the input is changed to another, let's say, del of t minus t1, then the output also becomes h of t minus t1, etc. I hope you understand that. And how it is coming, guys? It is coming because of it is time invariant system. Because of it is time invariant system. So let us see. Let us assume if I multiply this first input del of t by, let's say, x of 0, okay, then you know that it is linear system also. Yes or no? This is linear system also. Now, since it is a linear system, guys, so I hope I'm audible. Is there any network issue? Okay, great. As you can see over here, if your input gets multiplied with x of 0, then output also gets multiplied by the same amount, because it is a linear system. And since it is a linear system, then it satisfies something called as a homogeneity property. The amount by which input is getting multiplied by the same amount, your output also gets multiplied. So for example, if del of t was producing h of t, now x of 0 multiplied by del of t is definitely going to produce what input, what output? Come on, guys, it is x of 0 times h of t. Yes or no? That is the amount or quantity by which you multiply input by the same quantity, your output also gets multiplied. I hope you are getting my point. Okay. In case, let's say if the second input you have multiplied by x of t naught, then output also gets multiplied by x of t naught here. If the next input, if you multiply by x of t1, then the output also gets multiplied by the same, that is x of t1. I hope everybody is understanding this. So for the given LTI system, now let us come to the conclusion. For del of t, we were getting h of t. But del of t multiplied by x of 0, output is x of 0 dot h of t. Yes or no? Next, if I multiply x of t naught with del of t minus t naught, then the output is also x of t naught multiplied by h of t minus t naught. Okay, like that, if I go up to, x of infinity, then this will be equal to del of t minus infinity, and this is going to produce x of infinity times h of t minus infinity. Yes or no? And same way, we can go for a negative time scales also. We can go for a negative time scale also. How we can go about it? Very simple. Very, very simple, guys. Okay. For example, if I say x of minus t naught multiplied by del of t plus t naught, then you know that del of t plus t naught is going to produce what? H of t plus t naught. But can't you see your input is also getting multiplied by x of minus t naught? Therefore, output also gets multiplied by x of minus t naught. Okay. So this is what we called as a time invariancy property along with the linearity property. I hope you understand my point. So with this, let's say if you have taken a sum of them, okay, but in continuous time, how do we take sum of them? By integration, by an integration. So what I can say that if I want to integrate this, I can integrate this way, integrating over minus infinity to infinity. I would say, let us say x of tau, and here I can say del of t minus tau d tau. Then the same integration or the same summation we can consider at output side also. At output side also we can consider the same connection. Okay, so in that case, output will be considered as, so for example, if I say this is y of t, now I can define my y of t, since my input is a summation or integration of all those samples together, my output will be also the summation, or I would say integration of all those individual responses. So y of t will become integrating over minus infinity to infinity x of tau h of t minus tau d tau. And let me tell you guys, this is nothing but your integration for continuous time convolution. This is an integration for continuous time convolution. So guys, now you have actually learned how the formula of continuous time convolution is derived. I hope you are understanding that. If you have any query, guys, you can ask me. Okay, you can definitely ask me. So what I can actually write, y of t is, let's say if I assume that x of t was an input, y of t is the output, and h of t is an impulse response, the same integration, in short, I can write y of t is always x of t convolution with h of t. Okay, x of t convoluted with h of t produces y of t. I hope you are understanding that. Okay, so for a system that is LTI system, if the impulse response is h of t, if the input is x of t, and the output is y of t, then they are related like this. Y of t is equal to x of t convolution with h of t. Or I can say, in the form of integration, I can write integrating over minus infinity to infinity x of tau h of t minus tau d tau. Yes or no? Let me know. Are you understanding this? Is that easy?